All right, here we go. Today, we're going to talk about some fun stuff. And we are going to maybe meander in code and stuff. Yeah. By the way, it turns out that this text editor doesn't have spell check. So I had a typo on authenticity, I think. Now you're going to see how if I really can spell. So apologies for that. Maybe I'll add a spell checker at some point. Then again, maybe not. Okay. So for this episode, I want us to meander a little bit. I think I feel like I have a virtue. Maybe it's this thinking about complex things. Think deeply on complex problems and iterate. Maybe that's it. By the way, I'm trying to get closer to the mic, but it's on this thingamabob, so yeah, I continue to fail. And apologies for there's a little Merly hair. I try to de-shed it, but I don't always get it. Do I have something about? Maybe it's about curiosity. Okay, so never stop growing and learning. Yeah, we're gonna do some of that today, and sort of randomly look at things. Truthfully, there's gonna be things I'm just gonna randomly pick stuff. I have no idea what we're gonna look at, but we're gonna do it together. It's gonna be fun, I think. And I feel like there's something about this stay curious. Place others before you. Yeah, that's a good one. Practice empathy. Great. Yeah, works. Yeah, this one. At some point, we're going to get to this one. This one, I think. I've known a lot of people that are very, hey, we're actually demonstrating the meandering already, because clearly I'm somewhat imprecise on my direction today, and that's on purpose. But I do have a direction, and that direction is to meander. But I know a lot of people that are really brilliant people that are just phenomenal that can get stuck on this. And this can be this is really in my mind an ego thing. This aiming this need to be right. It's just such a silly thing because ultimately kind of like who cares? Like if your goal really is to do amazing things and just sort of like make the world a better place, why would it matter if you're right or someone else is right? Like as long as you're doing the work, um, yeah, it's just such a minor thing I think to focus on. And I used to fall victim to this a lot when I was younger because I wanted to prove to people how smart I was and that I could do important things, and it really held me back. I was just far too concerned about being right and having people uh, acknowledge me being right. And the truth is, for me personally, it was largely predicated on my own insecurity. I just lacked confidence. And oftentimes I find the people that need to be right, like myself, I just didn't have enough confidence. And as you build more of this quiet confidence, it's up here somewhere. I think that that's what happens is you become very confident and you focus more on the stuff that actually matters. And you can not get distracted by the minutia. You don't get distracted by, was it your idea or their idea or my idea? It's like, it's just a great idea. Let's just do this. And oftentimes, I think that really great leaders and really great collaborators, they focus more on giving other people credit than being concerned about getting the credit themselves. So if you're aspiring to be an incredible leader, I think this is one of the best things you can do is really spend more time thinking about others and how they're contributing this, placing others before you, and not being concerned about you being right, but really trying to succeed. And I think naturally people will be far more magnetized by you. They'll want to work with you. I mean, who doesn't want to work with someone that is constantly working to acknowledge you and your contributions? I think that that's something, at least I personally am very compelled by. I really like to work with people that aren't concerned about being right constantly. And part of the reason for that, just to be clear, my aspirations may be slightly different. The reason why this matters to me is when I work with people that are really concerned about being right, what I find is because there's so much focus on being right, they will often spend more time trying to defend an indefensible position because they need to be right. And that will actually send the team in the wrong direction, that they'll argue for something that doesn't quite make sense, not because it's going to succeed, but because they want to be right. And it's actually a really big distraction. So from my perspective, when I'm assembling teams and I'm working with people, of course I want people that are engaged, but I don't care really if people have lousy ideas. And sure, I want people to have valuable ideas, but the thing that I want the least is that people make suggestions that are not necessarily helpful. That's the first thing that I think is really, yeah, maybe this is something we can add to this. We're definitely meandering. Uh, but sure, having ideas that are great is wonderful, but it's hard to do this constantly, especially as you're brainstorming. But I think the big thing is when you have ideas that are not super great, to just move on, right? Like for example, when I first started doing GTT, I had a webcam that was not great, and I kind of liked it, but the feedback I was getting from the team is like, "Oh, your video is really bad, Goju." And so I didn't try to be right. I mean, I kind of like the webcam, but I looked at it and I realized, yeah, they're right. It is pretty lousy. So I just upgraded the webcam. I didn't spend time on trying to argue all the reasons why I like this webcam. And mostly it was like the size. Um, and it had like good software, but the actual hardware was, yeah, it was pretty lousy. And I could see that to succeed for the video quality, I think that they were probably right. And similarly, I think many of you have noticed I went through many different mics and I had all these various earbud things that I was trying. And part of that is I really liked the idea of being able to have like a little bit of background music playing while I was doing these recordings because, my addiction to music. By the way, we're going to do something in this episode where I'm going to play this video from Ren. And I hope I'm not going to get a copyright strike, but I'm going to do it anyway. And mostly I'm going to do it because I think Ren's awesome. And I absolutely love this guy. And if you look at his life story and his situation and the things that he's going through, things that he's gone through, it's sort of impossible for me not to support him. And so I may break the rules and YouTube may slap me with something, but I don't care. It's going to be worth it. It'll matter to me that I'm doing something that I feel is going to support Ren. And so, yeah, this is, I think, a good example of just trying to be authentic. And sometimes that means maybe breaking the rules. So anyway, we went down this. There's like we're 5 rabbit holes in, but there was something about this being curious. I could have sworn that there's something. There you go, lifelong learner. All right. Okay, well we get the idea. Is I suspect as soon as I stop looking for it, I'll find this. Yeah, this is another one. This I try to do this quite a bit. I used to take myself too seriously and boring, so boring. Just like laugh at yourself and make mistakes, and it's okay to be silly, and like you don't have to be a goofball, but like when you trip and you recover, okay, like yeah, you can make fun of yourself and not like look around and be so nervous that all these people are watching and you know are they going to think you're an idiot? No, they're actually going to think you're, well, idiot's too strong of a word, but they're probably going to judge you more harshly if you are super concerned about being uh, prim and proper and like angry or something because you tripped or blame someone else, like you pushed me or something. And I think people tend to be very forgiving and empathetic if you can lower your guard and not take yourself so seriously. So, yeah, like I said, meandering. Okay. Uh, After we meander all over the place, at some point we're going to get into this mentor packet analysis. This is something that we've been working on for a while. I'm going to bring it up here. And I'm just excited because this still needs a lot of work, so this is still early, but Taylor has been working on refining this so it works again. We had made some UI changes, and so obviously we want to get the page width and length all right. But what I love about this is fully automated. This is a completely automated process of generating this packet, and this is all from Mentor. And the script itself, I think, is mostly written in Python using like Selenium or something. And uh, yeah, like it's like the little things in life that make me happy. Like I feel like this is a really cool cover page. I just yeah, it has the right kind of polish and quality, I think, to yeah, be at my bar. My bar is a little crazy sometimes. So, and what I really like about this is lots of people that are very busy, they may not have time to like log into Mentor and look around. They want like, if you're an executive in your C-suite or whatever, just like tell me the answer. Just what is the answer? And so in this case, the answer is if you care about ClickHouse, then you maybe want to know these scores. Again, apologies. This is pretty wide. Um, we're working on resizing these things, but so there you go. There's your answer. Is pretty good, and 570 anomalies and 157 notables. Yeah, there's some work to do, but look, that's like 2 million lines of code. I mean, that's for 2 million lines of code and only 570 issues. That's probably better than I could do. So yeah, and it's C++. So this is impressive stuff. I will say though that this is what we were looking at before. Oh, and yeah, and so it also shows the summaries, which is like giving you the analysis of the different trends over the entire lifetime of the repository. I think that's pretty cool. That is that's one of the first things that I think I got pretty excited about outside of the mentor score is this ability to, yeah, this is probably too wide here. We probably want to narrow this down. I think Taylor watches all these, so T, if you're watching, you probably want to narrow this some, just because those are super long, single line sentences. Like 80 characters is approximately the good column width for human reading. And by the way, if you're curious about this width of reading, I think we discussed this, but there's been many like neurological, behavioral, and like psychological studies on sort of the right width of lines for reading. And what we find is that if it goes too long, it's very hard because our eyes have to go across, where because we have, you know, most of us have two eyes that are next to each other. We're much better at going up and down. We can just keep these focused and we see a width and we just read like this. This is why in novels tend to have this somewhat narrow space. Like you could make these much bigger, like textbooks, but what we find is that it's much better aligned for fast reading, fast visual processing, so you don't have to do this scrolling. So for those of you that are coders and you're annoyed by the 80 character limit, I've dabbled with this quite a bit, and I can say personally that, excuse me, once you get into like 120, 150 character lines, yeah, it's, especially if you have to start doing this, like this is not super awesome. By the way, not nitpicking on Taylor here, because a lot of this is stuff that I was working on before Taylor took it over. So if anything, I'm kind of picking up myself. But anyway, yeah, so you have the summaries, which is cool. I like these phases. This, I think, is really interesting insight. And by the way, one of the things that I kind of warms my heart is because Mentor's AI is the thing that identifies like these anomalies, it can then do a correlation on where these are deriving from. And it can see when, like in this case right here, right? You see that Mentor is saying in this case that so here's the initial expansion. So you're doing some just normal coding, but then starting in March 2011 up until about September of 2012, there was this rapid growth phase, but with increased issues. So these more issues were being introduced during this period of time, is what I suspect it's saying. Yeah, this period was marked by a significant increase in both lines of code and issues. However, issues grew at a faster pace than the lines of code. Ooh, yeah, this is not great. Suggesting the growing complexity might have introduced vulnerabilities. Yeah, and I think what was the range here? This is March 2011, September 2012. Okay, so let's see here. Oh, we can't see. These are just the score. There is like this issues thing that we can add here. Yeah, this issues one, but this one's turned off. Actually, let's truly meander. I think we've got ClickHouse over here. We'll just take a look at it. So it's March 2011 to click. Whoa. What was that, guys? That's cool. Now that we've got this, I guess I'll put this down. Click. ClickHouse. Okay. Oh, it's because I've got this. Oh, this. Oh, yeah. Okay. Clearly, we've got some weird visualization thing. Cool. I'm glad we've got this recorded. Now the team can try to reproduce this. Sorry about that. That flickering's not great. Okay, so Mentor was saying, let's look at the issues. Mentor was saying from 2000 about here. Let's jump to this point. Okay, cool. So we're 2011. We're in January. I can use the arrow keys and go forward. Yeah. Okay. So check this out. So lines of code, 8,000 lines of code. Not much. And then, yeah, this ratio is not good because you basically have only one issue, one anomaly for 8,000 lines of code. And you go back and it's like one issue, two issues. So they're doing pretty good. What I'm doing is use the back arrow keys. And so you can see the issues are pretty stable. And so the lines of code are increasing and they're not really increasing new issues. And then, and it's good. And then they jump up in the lines of code. It's like, what is it? 3,000 lines of code, but they introduce 8 new issues. And if we click into this, we can see that, oh, guys, yeah, this is, so this isn't that bad. Okay. Yeah, we really are going to, oh boy. Okay. I take it back. Okay. Again, not picking on anybody, and I've written a lot of code. I know early days of building new systems. Urs is going to love this because Urs and I. So I want to. I'm having a lot of fun today. It's been a while. I've been super busy with Merle and other stuff, and so I haven't had a chance to really go down a lot of rabbit holes on GTT, and that's been making me sad. And I finally, we finally got to a spot where I have a little more time, so I'm super excited. I'm in a pretty good mood to do this. You know, I got the dog with me, and I've got my 5 Coke Zeros. Yeah, I'm ready for a marathon. But so I've known Urs, my co-founder and chief engineer, chief architect for 25 years. This guy's a superhero. I mean, he's just incredible. His mind is just amazing. Just the way he thinks about things, his ability to see code and see systems in his head. It's amazing. And to see it mature over the last 2.5 decades. I mean, he was good. He was really good when I first met him. But he's like a demigod now. I mean, that's probably blasphemy, but he's on another level. And so that being said, I've written some code myself, and I'm no Urs, but one of the things that Urs and I noticed is, and Urs would agree with us. So I'm not saying anything that I think Urs wouldn't. If Urs is watching this, he's probably gonna be nodding his head. One of the things that I think there's mutual respect for both of us, right? Bidirectional. And I think we both agree that we're pretty seasoned coders and we both love, love code. We love it. If we could just stare at code for the rest of our lives, even code that maybe isn't, it's kind of breaking some never nesting rules here. Again, I've never seen this before. I was not expecting it to go this way. Okay. And I want to back up and say that This is a very good repo. Okay. This is a very good repo. And this kind of stuff happens in the early days of building new systems. This happened in Notica. This probably happened in Mentor. Like this is very common and this is very early for ClickHouse, so it's understandable. The the thing I'm trying to get to here. Sorry, it's taken me a little while because it's kind of breaking a number of the rules that I have. And I feel like Jimmy Fallon right now. It's like I love Jimmy Fallon, but he laughs a little bit too much sometimes. So I'm trying to get this out. Okay, let me get serious for a second. Um, okay, so in working with Urs, one of the things that he and I kind of have an understanding of is Urs writes code faster than I do. So he produces more code than I do, definitively. But I tend to produce higher quality code. So in comic books, this is actually what Paul Gottschalk shared with us. So Paul taught us this piece on who we are. Is when you're doing comic books, I guess. I'm not an expert in this, but Paul is, and he was saying you have a sketcher. A sketcher is they quickly sketch out the story and they're drawing all the stuff on how it's going to go. And then after the sketcher finishes, the inker comes in, and the inker has to be perfectly precise, and they get it exactly right, no mistakes, and everything is like crystal clear. So in this story, Urs is the sketcher. He sketches it. He's super fast, and he gets the whole outline done. And then I'm the inker. As I come in and I would look at this code and I would say, okay, I get it. You're sketching. And now I'm going to rewrite all of this. And so the first thing I would do is I would realize that 1, 2, 3, 4, 5, 6, 7, 8 levels of nesting is not acceptable. That's really bad. I also am not a fan of embedded literals. I also see a theme here is that these are multiples of 7. Just looking at the pattern recognition. And so minimally, you can just have these be powers of 7. I is equal to 1 times our constant. Like I literally could. What the heck? What is? Can everybody still see this? Okay, yeah. Okay, so you'd have int I equals 1. Oops. And then x equals whatever this thing is, shift. Should I do that? I mean, I know I'm kind of. Okay, and you get the drill, right? Yeah. And then on top of that, this could be a function. I don't know. I'm not a big fan of repetitive code because it's like you're going to fix this at some point, and then you're going to have to fix all of these. Whereas if you just did it as this little mini helper function, then you just fix the mini helper function, and you don't have to fix like all of these other things. So is that okay? Sorry, I just give me a second here. So, oh, I see. Oh, I see. Okay. Okay, I think I know what they're doing. Um, I know what they're doing. Why don't you just do this as a for loop? The speculation. Again, I've never seen this code before, so I don't know for sure. But what I think they're doing is they are trying to extrapolate out a 64 bit, yeah, 64-bit integer, and thus the shifts, right? Because this would be 56, and it's going to read the last 8 bits on this, and that's going to read from like, what is it, 57 to 64, something like that. And that's what this X or equals, is you're adding the bits and you're shifting them appropriately. Yeah. So what it's doing essentially is you've got this UN64 that is going to be assigned what's in this string of characters, and the string of characters is going to be in binary, thus the shifting. Yeah. I'm just trying to figure out this and it's going to take me a second to figure out what the bitwise and of the, because this is a specific hex value that we need to. Okay, let's just programmer. Okay, so I want to be in hex, and I want 7F, and then turn. Okay, yeah. Okay, so 7F is giving us this binary. Okay. So why? Okay, I'm just trying to make sure that we get the precedence order here right, because what I'm seeing here with this binary. Okay, let's. Interesting. So there's. I want to clarify. I'm probably not getting this right. But what's really interesting about this is it doesn't seem to me like it's exactly. It's like they're intentionally dropping this bit because that's the sign bit. And it's a uint. I think that's what they're doing. Okay, so the reason why I'm pausing is if they didn't do this bitwise and operation, and they're just doing the shift of 7 bits, then it like kind of makes sense, because they're taking this, they're dereferencing this integer string, which is these 8 bits, right? And then they're casting it to this thingamabob, and then they're shifting this to the left 7 bits, and then bitwise ORing it to X. And so they're like moving forward each time the 7 bits, which I guess in some sense is the clue, because they're dropping this. Yeah, hold on. One. Oh, okay. This is the first one. Okay, wait. 1, 2, 3, 4, 5, 6, 7, 8, 9. Hmm. Yes. Very interesting. Because, yeah, if it was including that extra bit, yeah, it would be 8. So 1, 2, yeah, because that's just the first 7 bit, or the first 8 bits. 7 bits. Yeah. Okay. 1, 2, 3, 4, 5, 6, 7, 8. It would stop here, and thus the missing uh, sign bit from all of these. And then, okay, so that this is my speculation. Again, I'm probably getting this wrong because I've never looked at this code before, and the debugger that I have in my head and trying to put all this together in real time, I'm probably missing parts of this. But what I think they're doing is, no, it's still very confusing to me because it's all in the same string here. Yeah, I think I'm missing something here. I really want to look at this a little bit in the debugger, because the part that I'm like a little bit confused about is I understand these. It's like it would make sense if each of these 8-bit increments were signed. And so you're going to drop the sign bit, right? You're going to drop the sign bit each time. And so you're just going to accumulate these. And just dropping the sign bit. But it's just like, so let me explain what's going on in my head here. This is where the tablet would really help. This makes sense if each of these integer strings is its own string, and each of these integer strings are signed. And so you would have 8 or 9, whatever, signed integers. And then you're going to assemble them together, and you want to drop the sign bit each time. Sort of makes sense. But the part that is confusing me a little bit here is there's something else going on, because you have like these strings don't quite make sense if this is the case that you're dropping these sign bits, because it's, and again, I think I'm missing something, is you are only moving 7 bits over each time, but the problem is if they're all concatenated, then they would have only one sign bit. They would have like a sign bit at the very end. And so you would only drop the upmost sign bit because they're all in this string. And then if they were individual integers, like the part that is kind of messing with me here is there's a disjointness about the 8 bits and the 7-bit movement. Is you're moving by 7 bits each time. And so you're dropping the 8th bit from each one of these I strings, but you're not. You're actually using it because you're only moving 7 each time. So it's like you're dropping it, but then you're using it in the next segment. You're not jumping by 8. So like you're, yeah, there's something else going on here that I think I'm not understanding is, or maybe that's the thing, is that this code could be more optimized. Because like I understand the anding here is they're trying to make sure that only the bits, these 7 bits, are being anded for this string, right? So, and then they want to make sure that it shifts on. Oh, hold on. They move it. Okay. No, I take it back. I get, okay. I think I understand. Sorry, I was ignoring the if conditional. Yes. Okay. This is inclusive of all 8 bits. So the if is dereferencing this guy, and then making sure that it is not null. What? Okay, so in my head, what I'm doing here is, oh, just the bottom. Yeah. Okay. So this plus plus on this Eyster is increasing it by 1 byte each time. That's the char. And so this first one, the reason why I'm doing this first is I'm trying to understand how that's progressing forward to this next guy. So then when you dereference this string, you're going to get the actual value. Yeah, you get the actual value here. And then you're going to AND this with this, which is that just the, sorry, my hex is yeah, okay. It is just the upmost bit. Okay, so you're dereferencing this and making sure that the upmost bit is on, and only if the upmost bit, the sign bit, is on, will this be true. All other cases, it will be false because of the bitwise and. And then you want to make sure that the I stir is still less than end. So you haven't run past the end of the string. And then if it is, then you're going to do this operation. Yeah. So this is where I was getting confused is I was trying to understand why you're shifting 7 bits, but what's happening with the 8th bit? Because if you're just shifting 7 each time, then you're still considering the 8th bit. This is how it's not considering the 8th bit. The 8th bit is being shifted on this plus operation. That's dropping it. And that's how that. So this is what I think. Now I think I actually understand is that they are doing. They somehow have a string of a whole bunch of unsigned ints that are. Sorry, they have a whole bunch. They have a string of a whole bunch of signed ints, and they're going to use the bits of this to construct a 64-bit unsigned int. And they know they need to drop the 8th bit from each individual byte that is these short, like single byte integers. So they're going to take the 7 bits of that byte and then figure out which ones are turned on, which is this AND operation. And then they're going to essentially set those bits to this guy and whatever other bits were set previously. So they're going to keep moving forward, marching forward each time. And they're going to intentionally drop the 8th bit, which is the sign bit. Then they're going to shift to the next byte. And that next byte is going to move forward 8 bits. And then they're going to repeat the process until they get done with all of these. And what's clever about this is 1, 2, 3, 4, 5, 6, 7, 8, 9 is okay. It's interesting. The code's pretty bad, but the idea is actually pretty interesting, I think. So they have put together 9 signed ints that then are going to be, they're going to chop off the sign bit on all 9 of those and then fuse those together to make a single unsigned 64-bit int. And this is what this is doing. That's what I think this is doing. This is a good example of like, you could have just added a single line comment here saying, I've got 9 signed ints that we're going to shove into this single unsigned int. But I guess that was fun. We got to do some problem solving. That's what I think is going on. Again, I haven't run this code, and I'm just trying to figure this out on the fly. I think that that's what's going on now. It's still a little strange, this check. Like this. Yeah, this is... Like, I'm literally following this rule over here of I'm avoiding racing to the end because I suspect maybe all the viewers want me to move on, but I'm me, so I'm not satisfied yet. And I'm doing this. I'm thinking deeply because this is actually... Sorry, I'm just looking at the clock trying to see how long I've been recording. This is actually somewhat complex. And I want to try to make sure I fully understand this. Not even mostly for my sake, as I'm just becoming curiouser and curiouser about this code. And I still really dislike this format. I think this is just so you could just do this in a for loop. You really can, because it's just it's a repeated conditional. I bet you later on they fix this. We're going to look at this in a second, and I'm pretty sure that this thing is going to be fixed. They're going to put it in a for loop, and they're just going to iterate the for loop, and they're going to do what I'm talking about here. They're going to create this, and then it's going to be equals. It's going to be less than 9. Yeah, they're going to do this. And then inside of that for loop, they're going to do some stuff. It's going to be like this. You may have to actually start on this one. And you may have to set x equals to... What's Poco, by the way? Okay, so you set... Oh, yeah, x comes in. Okay, so look, we'll... Sorry, I gotta fix their thing here. Whether they want me to or not. Okay. Now, we're going to do this. I'm going to leave this here. Have this. This is our width. Okay. So if x is equal to this is the first one. And then you're going to do something like this. Or what they do. I haven't been coding much these days. A little out of practice with that too. Okay, I'm just going to be a little lazy. I know, don't copy paste code. Do as I say, not as I do, right? That's what we want. And then this is going to be our I times, oh, I think we're going to do this, I times k multiple something. And then do that. Like, because that's basically what they're doing, right? Like, told you it was easier. Like, literally. I think that's it. Like, so this is basically what I saw in my head when I was saying, you just do this as a for loop. I think that's right. Just do it as a for loop. Right? The I is moving forward, which is going to increase the multiplication for the multiple. This thing is still moving forward, so it's moving forward each time. And now you have 2 levels of nesting. Cool. So, and not trying to get all like fancy or anything, just trying to explain what I was seeing in my head. Now, Yeah. So the insters, and this needs to be non-const because it's going to increase this const. And this is the width. And by the way, you'd probably pull these out too. The width is basically the number of ints that they're going to go through. So you want it to be, I think it's less than 9. Am I doing that right? Is it less than 10? This is where my one-off brain kind of struggles. I get these one-off things wrong like all the time. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9. You will start with 1 here, but you do the first one here, right? So the first one, right, because the way I counted this is 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 integers that you're putting together, right? And so we're doing the same thing, is that the first one is here. This is like the 0th bit. And then we start at 1 because that's where the multiple comes in. And the reason why we do this on the outside is this is the only one that's the assignment, just in case you were wondering. I could probably do it on the inside and set this to 0. Okay, if we want to make this a little bit cleaner, all we need to do is that. Okay, there you go. And now this is probably easier to understand. And this is what I mean about like how Urs and I would get into this, is that this is like how I code. It's like kind of not making me happy because it still feels like eh. And there's like, how do we do this? Can I do just this? Am I allowed to do that? I think. I think that's how I do it. Because I want these two to be int const, but I want this one just to be an int because I'm going to increase it. And then I set x to 0. Because I'm going to do this here, and I need to make sure that all the bits are set to 0, which is basically what they're doing here. They're doing 2 things at once. They're setting all the bits that are not the first 7 bits to 0, because that's what's happening with this guy. Because this is turning this into this thing, a uint64, and just the bits, the first 7 bits that are turned on are the ones that are going to be on. So we have to emulate this. This is why you can't remove this here. If you remove this, we don't know what x is when it's passed in. X could be a non-zero value. That's why we have to do this if we want to emulate this behavior. Now, it could be that x is 0, and if x is 0, we don't have to do this. It's fine. But if x is not 0, and they're using the byproduct of that, this will clear all the bits that are beyond the first 7, which is what this will do, I think, then we need to emulate that with this code over here. And that's why, so we can either do it the way they're doing it here, which is why I put that on the outside of the for loop, or we can do it inside of here. But in order to do that, we have to reset x. So unfortunately, I don't know how we can get rid of this one lingering line of code. I mean, I do know, but kind of like no matter how we do it, it's a little bit kludgy. Okay, and I'm still not happy with this code. So I'm going to do something else here. And I'm just going to be lazy about this. And because I feel like we've all thought enough about this code. That we want to move on. This is what I was talking about like how Urs and I will have slightly different levels of our pedantry. I like this more. Shoot. This. No, that's still. Okay. Sorry, it's going to take me a second here because I need to think about the short-circuited logic. So the plus plus I is still going to happen, which is going to move it forward. Oh. This is the problem. This is the problem that we have now because the first one does not move Eister forward, right? All the subsequent ones do. And so I'm actually glad we went in here now. Okay, let's look at this. So I will be 0. Oh, whoops. We need to set I equal to 0. I'm really glad we looked at this. Because you guys are making me change all this. Or maybe I'm making myself change this. Okay, so I is going to be equal to 0. And you need that to be 0 because you don't want the shift the first time. So 0 times 7 is going to be nothing. And so it's not going to shift. No shifting, which is exactly what this first line of code does. And then it's going to OR this, and then that should be okay, right? Then, this I equals 0. Then it's going to do this check, and it's going to say, are you... Whoops. Did I drop that? Okay, yeah. Is the sign bit set for this? Okay. And is this less than the len? So if that is not true, you're out of here. You're done. We're done setting this. If that is true, then continue. Then J will get increased. And J needs to be less than the width because we're going to do this no more than the 9 times. And we're still going to exit the first time it runs into any one of these where the sign bit is not set. Right? Now it goes through the second time. And the second time is going to OR equal this thing. Eister has now been moved forward by 1 byte, which is done here. Okay. And then we're going to append it with the 7 bits. That's going to do that thing. Then we're going to do the shift. And I is going to be 1 now. 1 times 7, it'll do the 7 bits. Then it'll increment I, so it'll make it 2. But it won't do that until after the multiplication. By the way, we could just do the plus plus outside of this, but we're just trying to like follow. I mean, okay, I did it. Okay, it's my fault. Is this a conditional? This isn't conditional. Okay, so I'm not breaking my own rules in that I'm doing a mutating operation inside of conditional. It's still a bit much. Look, okay. Yeah. Okay, now we're having fun. And I mean, in some sense, yes, I know what you're all thinking. We could just use J now. And again, this is why Urs hates me a little bit. He's like, are you done yet? No, I'm not done. It's not totally, completely perfect yet. Just give me a second, bro. Okay. We should submit this as a pull request to ClickHouse. Maybe I'll email the ClickHouse people and be like, hey, can you guys watch the first hour of this episode? And just, and then they're going to be like, yeah, just look at, hey, Goju, doofus, look at the code 6 months later. Yeah, we already did that. Okay, thanks. And by the way, there's a bug in your code, which I suspect there may still be a bug. Well, I'm liking this more now. Now this is starting to look like Goju level code. Okay, so we've got our multiple, we've got our width. We're down to just a single floating variable. I like that. We're doing the increment there. We have this at 0 when it needs to be, and non-zero when we want it to be non-zero. The multiple is defined for the 7. The width is still 9, which is right. It does increment the I stir at the right place. It checks the sign bit when it needs to, and it breaks in the event the sign bit's not set, or it goes past the end. Whew, it wouldn't have been. Keep doing this. Okay. It's the const thing on the right side. I don't know. I'm a little strange, but once you do a lot of template coding, trust me. Yeah, if you're not doing a lot of template coding, it's probably not that big of a deal. But if you do, like I tend to, because like the next thing I'm thinking about is like, let's make this like templatized. Like, why does it have to work with just a char? We can make it work with like other things, like wchar. And I mean, you could, right? Oh, and this isn't supposed to return. Uh-oh. Oh. I think this will still work. I realize that I may be the only one of all the people that watch this that care this much about making sure this is right. But if you look at their logic over here, if the sign bit's not set, the short-circuited logic will exit. So it'll check this and say, is this true? It's not. Shoot. Because I've inverted it. Oh. Okay, so sorry, guys. Maybe what I'll do is once we finish this, I'll click end and we'll upload this one. And then we'll do a follow-up where we actually talk about the stuff that I said I was going to talk about. And then we can maybe get the copyright strike by watching the Sick Boy on Ren. But let's go back at this and let me explain to you why I'm kind of struggling with this piece. Now we know this is like real Goju code is we're adding. Okay, so what I'm doing over here is I'm trying to observe the patterns here. So if the 8th bit is off, they will not do this plus location on this I stir. And why does that matter? Because they're then going to not do this. They're going to jump down here, and then they're going to go one beyond it. Yes. Okay. That's what they're doing. That's what they're doing. they're correcting for the fact that their code will not execute this. So if the 8th bit is not set, they're going to exit, but they haven't done the plus plus on the ISTER, which means they have to do it here because they want to show that they actually processed this, because I think that they're using the sign bit to denote if the uints are concatenated together. That's what I think that's the purpose of the sign bit, to tell you how many of these ints are actually being concatenated together. And the moment you see the sign bit is off, then it's no longer a concatenation. That's what I think they're doing. It's pretty clever. It is a compression technique. But the thing is that this is going to be a whole bunch. This is going to be a bunch of binary information that they're segmenting into 64-bit ints capsized. But it's a massive string. So this could go really, really large. That's why you have the check both for is the sign bit and do you get to the end? Because I suspect they're going to read many, many ints off of this. This is probably run inside of some heavy loop, right? So what they need to do is when the sign bit's not set, they're going to exit, but they need to show that they read this byte. So they move forward one. Well, our code, it works in a slightly different way, is that we check if this sign bit is set. So if the sign bit is not set, this will be false. False and anything is false. Yep. And then it'll invert it. It'll make it true. And then it'll break. And we still need to do it. Yeah. Cool. And then if it's true, so this is true, the sign bit is set, then it'll do the increment. And then if, yeah, and if it's at the end, you don't increment it beyond it because you already processed this one. You processed it here. Now it's interesting because you've inverted it. I mean, we're emulating this now in the same order. The only difference is that we have the case where you set X to the default value inside of the loop. Yeah. Okay. I think now I have, because we haven't run this code and I haven't compiled this code, I'm still not 100% sure that this is right, but I have a growing sense of confidence that we're getting approximately close to this being right now. If I speculate, I'd say maybe feeling like maybe 80% confident that we have this close to right-ish at this point. Yeah. Maybe what we'll do as an exercise is we'll bring up Visual Studio and we'll drop this in. I'll save this off as a backup file. And we'll come back to this and see if this is actually, we're going to have to make some changes because I don't know what this POCO thing is. But we can just store it as like an actual uint. But I think we're approximately close, and I think I now have a better understanding of what it is they're doing. I don't think that there are, before I was mentioning that there are like a whole bunch of gaps, and like I didn't understand, like, why would you do this? Why would you do that? Like I understand now the sign bit. I understand, I think, what they're doing with it. I think that this is a compression on these bits. And I get that they move the full byte forward. That all makes sense. I get why they check the end and they check this, because this is a termination characteristic for the integer that you're processing. This is a termination characteristic for you have reached the end. And I also understand too that this what you're doing here is somewhat complicated. So I can understand how the programmer would probably be like, look, it's already really complicated to get this exactly right. Let's just write out the full thing. And so that's why they did these embedded ifs. But I still think that, I mean, at least for my level of pedantry, and I'm super pedantic, right? Is that I see stuff like this and I just like this would just keep me awake at night. Um, so I much prefer this. And part of the reason why I prefer this too is, look, let's just be honest here for a second, right? Okay, let me show you something. What about this? What about that change? Mm-hmm. Because you want to make this work with my version, here you go. Done. I think that's it. All I had to change was the number of loops, the number of loop iterations, because it's not going to go 9 iterations. It's going to go double that because it's 128 bits. And I just changed this type. And the truth is, like, if I were to doing this like the real way, I wouldn't even change the type. And this, I would pass this in as a parameter. So I would make this an int const k width, and I would have it have a default value of 9. The multiple is somewhat embedded into the behavior, so I'll leave it there. And then what I would do is I would make this a template, type name t, and this would be t. And now I can call this for an int 64, an int 32, an int 128, an int 256, and the only thing that needed to change is just this guy here. You might not want to set it as a default, so people have to supply it so they can't accidentally get it wrong. But if the default behavior is that that you want it to work with 64 bits, then this would give you that behavior. I think that's right. Okay. This makes me happy. Yeah. Okay. We spent an hour and almost 20 minutes on this, and I need to refill my soda situation. So I'm going to pause now or I'm going to hit end, because I do have a feeling that if I do this sick boy, I might get a copyright strike. I'm going to do it anyway. But then only the shorter video is going to get the copyright strike. And this whole madness of going down this path with ClickHouse will not be part of it. Speaking of which, I promised that we would look into this to see that they fixed this. What file is this? Can I use the arrow keys for moving forward in the file? Okay, this is var int cpp. Okay, something we can do in Mentor is we can do this. We can say, okay, so this is going to flag all of these, and it's only going to show us these issues. So what I'm going to do is I'm going to use the arrow keys now to move forward, and we're going to see how long these last. I don't know how long they last. So I'm going to hit the back arrow first to show that they're gone. So in January of 2011, they're not there. But then in May of 2011, they get added. Okay, I'm going to hit the next arrow. Okay, so they're still there in September. They're still there in, oh, and that's just a side effect of it doesn't, the regular expression is inclusive of whatever. Or it's, yeah, by design. So December is still there. Still there in 2012. Wow, I really would have expected. There we go. Okay. In 2016, in June, it still exists. And then in October of 2016, it's gone. Okay. We're going to do something here. We're going to go back into this. It's var was like var int cpp, var int dot h. Oh, they changed it. They made it an H file. Okay, var int dot h. Okay, that's probably where it's going to stay. Okay, now what we're going to do is we're going to go back to this just to, okay, we're going to move forward. Now it's gone, right? Okay, so it's gone. Then we're going to go into this instance, var int dot h. We're going to go into the files. We're going to look for var int. Is it case specific? Var int. Uh-oh. I don't know that I've gone this. Maybe if I do a star var, what does this do? Care about this. Does it give me the full path on that? Okay, I know. I think I have an idea of how we can do this. I'm gonna go back. Little. Okay. Back to this guy. Okay, no, I'm gonna go back here to these files. Oh, see, it does work. Oh, maybe it's because it just wasn't on that page. Okay, so but var int, at least where it is right now, is in dbms source. Okay, dbms source. We're gonna go back over here. We'll obviously make this better as we move forward. Okay, it's gone. We go into files. It's dbms. I think it's probably in the include. DB. I don't think it's going to be as simple as that, but that's okay. At some point, I may do the streaming thing. I used to do this on Notica quite a bit. This is where streaming crowdsource would help quite a bit because all of you could be on chat screaming at me when I miss it. And I could just look at you guys and say, "Do you see it? Do you see it? Do you see it?" Okay. I wonder if you can just do something as simple as like, I wonder if I do, okay, let me try something else. Okay. I know if, interesting. And it was in, okay, hold on. There's a new thing I just thought of. Okay. What I just thought of is maybe they did get rid of those files. It is var, okay. Here's, but I think in this one, it's still there, right? Okay, this time, is it still there? It's this 2 thing. Okay, and where is this? This is in var int. Doesn't give me the full path. Okay, but it probably doesn't because it's just so long. This is var int dot h. Okay, var int dot h. It's somewhere in there. Var int. Huh. Strange. Very strange. Oh. So here it is. And it thinks that this is in var int dot h. Click on files, but then we don't see a var int. Okay, let me just check one other thing here. I realize I'm going way down this rabbit hole. Okay, so here we go. We got this. Now I'm just going to click on the files. This says it's in var int.cpp. I just want to see if this. I'm not as familiar with. Yeah, see, here it is. It does show it. So in this case, I see it. Do the arrow keys work here? No. So it's strange because I see it there, and then as I move forward in time, where it exists, okay, it still exists here, right? And then it says it's in var int.h. So I go into files, and if I do var int.h, I do not see that file. So I don't know if this is a bug with Mentor. Let's try something. I'm going to hit the... I'm going to go back here. I'm going to go here. I'm going to go one back. Okay, so I'm going to go back to the last inference point. I'll go back two. Okay, I'm going to go back into this. And then I'm going to go back into the file. And I just want to see if I can see var int. Okay, so var int is here. Maybe we're one ahead. Okay, so here's the old... Oh, they changed it-ish. Or... No, this is... Okay. No, this is our guy. Whoa. Guys. Oh man. See, this is actually we thought this VOD was going to end. This is the reason why I don't like these things. Like this is why I get so pedantic. Maybe this gives all of you a deeper understanding of why I'm like so a little bit religious about this. Is we spent some time to write this, right? And that took a little while. But now and remember I was saying like we could just make this templatized, right? And we did. So, but this is the kind of stuff that tends to happen when you don't do this, right? Like this code did not exist initially. At least I don't think that it did, because this mentor is probably not going to be too thrilled about these things, or maybe that passes. I'm not sure. We'll have to see. But this did exist, and what you can see very clearly, right, is there's a pattern recognition going on here. These are this uint64, and it's doing a similar thing. It's doing this in and then this out, right? But we can do that over here, just with this, and then on top of this, you have another one, right? You got this one doing all the ins, and hold on, that's not it. You got another one doing this, right? And so this is what can happen. And I'm not trying to get too judgy. Again, ClickHouse is a great repo, but even great coders and great software systems can go and do things maybe not super great. And I think this is like a good example of that is they kind of let this code run away from them and they're just making it worse. They're perpetuating the worstness of it. Um, like look at all this, and for all of you that are watching this, you probably can see the pattern, right? And this pattern can be captured by this. Like I mean, hopefully you believe me at this point because we just spent an hour building this and I feel like we mostly got it right. We'd probably want to actually run this code and do all that stuff and debug it. But I think the essence of what it's providing is hopefully pretty clear. Basically, this file, which is like 500 lines of code, if you followed this method, not methodology, this method, of solving this. You could probably reduce the lines of code in this file to, this would probably be less than 200 lines of code. Yeah. This is, let's say that's 50, that's 100, let's say 150, that's almost 100, that's 250, that's 300 something, that's, yeah, you're going to reduce the lines of code on this quite a bit. It could be that, yeah, you're probably going to reduce this by like 300 lines of code if you do this. And less code that basically does the same thing. So there's no, not that I can tell, I don't think that there's necessarily like a big performance degradation. It's also far easier to maintain because like these embedded literals is just really not great the way they're doing these embedded literals. And again, it's a matching thing. So you have buff 7 here. You have this one goes into buff 8, but this one goes out to buff 7, right? Because this is the successful case. This is the unsuccessful case. You can emulate this type of thing in this loop. I haven't looked at all these, but maybe as an exercise, we'll do that. But so hopefully now you're actually compelled into why I'm so pedantic on things like this is I've been writing software for a long enough time that when I see this, I do have this sort of not great reaction to it because I've seen this type of thing emerge. And now we've got 2, 3, 4, 5, 6, and that's just in this file. We don't know if this exists somewhere else. Right? Like, okay, this one's good, but I suspect this pattern might, I mean, if you get 7 of them in that file, I think that you could likely have more of them elsewhere. So on that note, one of the things that Goju is working on, and this is the virtue that I need to be better about, because I'm constantly trying to grow, is I need to not judge people so harshly. I need to judge myself more. So I'm not trying to be judgy. I want to again close and say that ClickHouse is a good repository, right? That they, how do I get to ClickHouse here? ClickHouse. This is a lot of code. You know, nearly 2 million lines of code, and they did have a little bit of a dip here. That's how we went down this rabbit hole. As you could see, their score dropped, and Mentor was complaining about this little dip, which I think is probably pretty good. But then they recover from it, and they've stayed pretty well. I mean, here you can see a little bit of a dip again, right? So they're trending in not such a great spot. And if we click on this, we can probably see 282 issues, 301 issues, 500. Oh, whoa. Okay. Wow. Okay, that is not, wow. That is not a good jump. Okay, 282 to 301. is not a big deal. But 301 issues to 508, like, okay, we we may reach out to ClickHouse and just warn them, because you can see this drop. So this is the point where they have 301, right? This spot here. And then you can see the mentor score drops. And they are adding quite a bit of code, right? So it goes from 1.7 million to 1.8 million. And so this is a lot of code that they're doing over the holidays of 2024 to February of this year. And I got to tell you too, there's some interesting patterns that we've seen with like holiday coding. But that maybe is a topic for the next VOD. I am literally going to end this one now and share that that was awesome. And that's the kind of stuff that I think that happens when you meander. Let's do more meandering. I had a great time. I feel like I learned quite a bit. And I know a little bit about ClickHouse's integer bit compression system, which is kind of clever, if I'm being honest. I think that's pretty cool. So thanks, everybody. And I may be back in a couple hours with us looking at Ren, Sick Boy.